Good afternoon. Welcome to the new season of our seminar series running from February to April 2025. So we are excited to have you with us as we embark on our another round of engaging and impactful discussions. My name is Noel de Guzman. I'm the acting chair of the Department of Economics of Ateneo de Manila University, and I will be your host or moderator for this event. Today, we will have a 40-minute presentation followed by a 20-minute Q&A, providing opportunity for more discussion. Okay, so just a quick reminder of the house rules. So first, let's please let the speaker finish the presentation before we open the floor for questions. For our Zoom participants, kindly stay muted and keep your video off during the presentation. And then when we move to the Q&A, simply raise your hand if you have a question virtually. And once acknowledged, you can unmute and ask your question. Alternatively, you can send your questions via the chat box or chat with me directly. So lastly, materials from from the seminar will only be shared on our website with the speaker's consent. So today's presentation titled Households Preferences for Alternative Renewable Energy Technologies, an attribute-based choice experiment survey in Metro Manila, Philippines. It examines Metro Manila households' willingness to pay, or WTP, for increased renewable energy or RE adoption using a choice-based conjoint analysis. The findings highlight opportunities to boost support for biomass projects and suggest targeted information campaigns on lesser-known RE technologies, especially for high-income households and female household heads to enhance awareness of RE's role in climate change mitigation. Our speaker today is a colleague, and she is Dr. Rosalina Palanca-Tan, professor at Ateneo de Manila University, specializing in environmental and natural resource economics. She holds a PhD in economics from Sophia University and has dedicated her research to exploring the intersection of economic policies and sustainable development. Professor Tan's work contributes to advancing economic strategies that address environmental challenges and public health concerns. So please let us join in welcoming our distinguished speaker with a warm round of applause.
Thank you for that presentation, Dr. De Guzman. So let me start my presentation. My slides, please. So I will be sharing with you today our research on renewable energy in the Philippines. The presentation is actually, the research is actually one of the studies in the cross-country or multi-country research on renewable energy in Southeast Asia, which was initiated by the University of Tokyo in Japan. Now, for this presentation, I shall be presenting the two journal articles that were produced out of the study. Can you please move to the next slide? These are the two papers. The first one is estimating the willingness to pay for renewable energy in general using contingent valuation. The second one is estimating willingness to pay for each RE technology, which are, the technologies are biomass, solar, wind, and small-scale hydropower. And this is using choice experiment. Next slide, please. Now, to give you a brief background, okay, so we know that the Philippines, like other Southeast Asian countries, because of its topography and socioeconomic structure, is highly vulnerable to climate change. Now, the Global Climate Risk Index of 2021, the index measures the extent by which countries and regions are affected by impacts of weather-related extreme events. This study ranked the Philippines number 4 or fourth most affected country during the period 2000 to 2019. So as such, the Philippines participates in global warming mitigation efforts, more specifically the Paris Agreement of 2015. And in this agreement, the Philippine government made a commitment to reduce its GHG emissions, greenhouse gas emissions, which is mainly carbon dioxide, by 70%. And in 2021, the Philippine government even updated its commitment and increased it to 75%. Now, for this, the government came up with an RE Act of 2008, which provides incentives for private sector's participation in RE investment. Now, the act led to the National Renewable Energy Program, the first version of which covered 2011 to 2030. And the target for this program is to raise RE-based power capacity in electricity generation to 50%. And for this, people's support is important. Why? Because the RE program would entail substantial cost, which will be passed on to consumers in the form of higher electricity prices and also through government incentives, no, and subsidies to be given to the investors, which will have to be paid by our taxes. Next, please. Now, so the objective of the research is to contribute to evidence-informed renewable energy program by looking at people's preferences and willingness to pay for RE. So specifically, we want to estimate household willingness to pay for RE and determine the factors that influence willingness to pay. Next. Now, so I shall be presenting the two papers. So I'll start with paper 9, number 1, which I said earlier is estimating willingness to pay for a general RE program. General meaning we will not specify the particular technology, RE technology to be used. And this is willingness to pay to increase the share of RE in electricity generation capacity in the Philippines from 30% in 2020 to 50% by the year 2030 using the contingent valuation method. Next, please. Now, contingent valuation. I'm sure some of you have heard of this methodology. For those who have not heard of the methodology, let me explain very briefly. Contingent valuation is a non-market valuation technique. Next, please. So what do we mean by this? Okay. In economics, if you want to know the benefits that people get from a good or service, you look at the market. And the market price is an indicator of the benefits that people get obtained from the good. Example, so we have here on the screen a supermarket. There are different goods and each good has a price tag. Example, this say baby stroller, say the price tag is 2,300 pesos. Now, if people buy the good at 2,300 pesos, that means that the benefits that they assume they will be getting from the good is worth 2,300 pesos. That's why they're willing to give up their money for this amount of money for the good, for the stroller. Now, not all goods and services are traded in the market. And if that is the case, we cannot use this market valuation technique. We have to resort to other valuation techniques. And particularly in the case of environmental goods such as clean air, there is no market for clean air. So clean air is not sold in cans or whatever. And many of the environmental amenities are not sold in the market. The programs of the government that come up with better environment to service the people would not be sold in the market. So what do we do? How do we estimate the benefits for such goods? Can we go back to the previous slide? So we use contingent valuation. And in the second line of this slide, we are saying that contingent valuation, just like choice experiment, which is the method for the second paper is a stated preference approach to non-market valuation. And we simply mean by this phrase that in a contingent valuation as well as choice experiment, we ask people to directly state their willingness to pay for the good and through a survey. And that is why it's called stated preference. So willingness to pay that we get from a CVM or a choice experiment study is actually a monetary estimate of all the benefits that people can derive from the good, tangible and intangible, present and future use and non-use values. Now, why is this so? Because we have to explain all of this. What is your maximum willingness to pay for the good or the service? And the respondent would give a certain amount of money. In the DC willingness to pay question format, we ask them, will you be willing to pay a certain amount of money for the good? And the respondent simply answers yes or no. So what did they use for this study? And for most of my studies, WTP, CVM studies. So I most commonly use dichotomous choice. Why? Because it is a question format that is easiest for the respondent to answer. And why? Because it more closely resembles the market situation. In a market, as I shown earlier, we have a good, all the goods, and all the goods, each of the good has a market price, a price tag attached to it. And the people decide to buy or not to buy the good at that given price. Next, please. Now, CVM is a survey-based approach. So the first crucial step in conducting a CVM study is to formulate the questionnaire. And for this study, we actually started with a standard survey questionnaire developed by Tokyo University. So that was for choice experiment. So the first thing we did with that questionnaire is to replace the choice experiment part with the CV question series. And then after that, we conducted a series of focus group discussions, KIIs, key informant interviews, to be able to modify the questions, the statements, the response choices in accordance with the Philippine context. And so we came up with a 4-part questionnaire. The first part asks detailed questions about electricity consumption of the household. The second part gives the CVM scenario, which includes the willingness to pay question. The third part asks awareness and attitudinal questions regarding environmental issues, climate change, renewable energy, and electricity pricing in the Philippines. And last, we asked demographic and socioeconomic questions regarding the respondents and their households. Next, please. So, of course, the central part of the questionnaire is a valuation scenario. So here we first discuss the current and projected electricity power demand in the Philippines. And then we proceeded with the currently installed electric power capacity that was in 2020. And we divided them into two, the coal, gas, and oil-based, the highly polluting sources, which comprise 70% in 2019 and 2020. And then the remaining 30% are sourced from renewable energy, which at that time was mainly large-scale hydropower and geothermal. And then after that, we gave them short descriptions with illustrations of the different RE sources: solar, wind, large-scale and small-scale hydropower, geothermal, and biomass. And then we proceeded to discuss the National Renewable Energy Program of the Philippine government as part of its commitment to the Paris Agreement. And we told the respondents that it entails, or the target is to increase the renewable energy share to 50% by the year 2030. And then we asked the willingness to pay question. Next, please. Now, this is a willingness to pay question. It is framed within a referendum context because we are asking them to value a public policy or program. So the exact question is here. You can read it. Suppose the RE program will increase renewable energy share to 50% by the year 2030. And suppose this would entail a cost, an additional cost for the household, which is a percent increase in the monthly electricity bill of the household. Would you be voting for the program and be willing to pay the additional cost? Now, can we go back to the previous slide? Now, the price that was stated in the DC choice willingness to pay question are 5, 10, 15, 20, and 30%. So how did we come up with these price levels? We decided on the minimum and the maximum by undertaking a series of pretests for possible minimum and possible maximum bid levels or price levels. This is demand-based. This is not supply-based. So we did a pretest for our target respondents. And 5%, the rule of thumb is if you're generating about 90% of the pretest respondents saying yes to the minimum bid, then that could be the minimum bid, amount 5%. And for the maximum bid, it has to be only 10% of the respondents saying yes to that bid. So that's how we decided on 5 and 30%. And then we just allocate the 3 other bids in between 5 and 30%. Can you please proceed to the next slide? Next. Now, this is just a survey site. Well, our target respondents are households in Metro Manila that are connected to Meralco. So we got our respondents from Quezon City for the Eastern District, and then Caloocan City for the Northern District, Makati for the Southern District, and Manila for the Capital District. Next, please. So how did we analyze the responses to our willingness to pay question? So we used the framework of Hahnemann based on the random utility model. The random utility model simply says that utility is a function of whether the project is implemented or not, income, and M is the vector of other household characteristics. So we assume that indirect utility is linearly additive of the deterministic and the stochastic components. V is a deterministic component and epsilon is a stochastic component. Anyway, we specified that the probability of a yes answer is equal to the probability that the utility with the program is greater than the probability without the program. So our dependent variable is actually a binary variable. It is the H variable, which takes on the value 1 if the answer is yes to the willingness to pay question, and 0 if the answer is no. So we ran binary logic regression procedure to come up with the estimated coefficients of the explanatory variables, income and other household characteristics. And we use this formula, the second to the last line, to compute for the mean willingness to pay, which is simply, in the numerator, we have the vector or the matrix product of the estimated coefficients with the mean values of the respective explanatory variables, divided by, of course, that is except the price, and divided by the estimated coefficient of the price variable, which is the bid level. We also have a formula for non-parametric mean, and this is a Turnbull formula. That's the last line or the spouse of the household head to answer the questionnaire. And then about 26% of respondents are female, which are the spouse of the household heads. And then the average education of the respondents is 3.3, which specifies, now this is 3 is for high school and 4 is college. So it's between high school and college. And then the average number of members in the household is 5. The average income of the respondent households is 44,940. Also, on average, the households consume 337 kilowatt of electricity a month. In value terms, this is 3,010 pesos. And finally, about 36.8% of the respondents are delayed in their electricity payment. Next, please. Now, we asked several awareness questions and opinion questions, right? And the first question we asked is the most serious environmental problems perceived by the respondents. So we gave them a list. The list is here. And then the first most serious turned out to be air pollution. And then the second one is solid waste management. Okay, next, please. Now, we also asked them to agree, the respondents to agree or disagree with statements regarding climate change and renewable energy. And we see from here the dark green and light green would be the proportion of agree answers, strongly and agree answers. And we note that most respondents, about 95% or more, 98% are concerned about climate change. About 95% believe that climate change can harm his households. And then we have about a big proportion of respondents also. This is 58 plus 27, so about 85%, no, believing that renewable energy is good for the environment. So we look at the last two lines, no. So we see here that people hear more about climate change than renewable energy, because we have majority, about 60% of respondents saying they hear a lot about climate change in the news, but only about 20% of respondents saying they hear a lot about renewable energy. And then finally, the third statement, no, we have here about 68% of respondents saying that agreeing with the statement, science and technology will eventually solve our problem with climate change. So they believe that science will find a way, no, to get carbon dioxide out of the atmosphere and bury them somewhere. Next, please. Now, regarding electricity pricing, we note here that people are not so open to further increases in electricity price. So we have a very small percentage of people, no, saying that a substantial proportion of people, 27 plus 18, around 45, more than 45%, saying that they prefer the cheapest source of electricity. They don't care about the source of electricity, that is, whether it's good or bad. So they just prefer the cheapest source. And then we have in the second line, the government should provide electricity at a higher price to encourage electricity saving practices. And for economists, we are quite familiar with this, right? Using market-based instruments such as price to actually control the demand for the good. Example, we have sin taxes, right? So alcoholic beverages and cigarettes are priced higher because the sales tax on this are higher. And this is actually to discourage consumption of this. So we can also discourage wasteful use of electricity by raising the price of electricity. But we see here that 10% of the respondents, only 10% are open to this, no? And why is this so? Because of course, any price increase, consumers don't want price increases, especially for electricity, because in the Philippines, electricity is very expensive. In fact, in Southeast Asia, I guess we have the highest electricity price. Next, please. There's a chat. Okay, 20 minutes to go. Next. Yeah, next slide, please. Okay, this is self-assessed knowledge about CDRT. CDRT is carbon dioxide removal technology. As I said, this study was initiated in Japan, no, by University of Tokyo, and so they do a lot of this technology innovation. So as we see here, a lot of people in the Philippines are still not aware about carbon dioxide removal technology. This has something to do with removing carbon dioxide in the atmosphere and burying them in the sea or underground. So 40%, 39% of respondents have not heard about this. 22% said they have heard about this, but know nothing about it yet. 27% or 28%, they say they know very little about it. So only 1.6% of respondents are saying they know a great deal about it already. Next, please. Okay. This is a bid function, and this is simply a graph of the proportion of yes answers vis-a-vis the price or the program cost. And we see that when the increase in electricity bill is 5%, 64% of the respondents said yes, they're willing to pay. But as the price of the program, the cost of the program increases, the proportion of yes answers also decreases. Now it's for the highest bid, 30%, the proportion of yes respondents was only 34%, only a third. And this is consistent with the law of demand in economics. The higher the price, the less is the demand for the good. Next, please. Next, please. And there are other tests, no, for consistency and validity of willingness to pay. So we check if those who are considering climate change as the most serious problem is more likely to pay. And indeed it was, no? And so we have this consistency, but because of lack of a time, can we just move on to the next, please? Next, please. Okay, so this is the result of the regression analysis. We ran 4 regressions. Basically, just each regression has a different set of explanatory variables. The most basic regression is model number 1, where we only included the economic variables price, the program cost, and household income. And we see that both coefficients are statistically significant. So price has a negative coefficient, meaning the higher the cost of the program, the higher increase in electricity bill, the less likely is the responding voting for the program and willing to pay for the program. Household income has a positive coefficient, meaning the higher the income, the more likely is the responding saying yes to the program or willing to pay for the program. And this is again consistent with economic theory. The higher the income, the greater the demand for the good, given that the good is a normal good. Now, model 2 includes socio-economic factors, variables regarding the respondent. And out of this, sex, age, education of the respondent, and delay in electricity payment and household size, only household size turned out to be statistically significant, and it has a negative sign, the coefficient, meaning the larger the household, the less likely is the respondent be willing to pay for the renewable energy program. And this is expected because as the bigger the household, the more financial burden the household has, and therefore the less capacity to pay for the program. Now, models 3 and 4 actually re-estimate model 2, but we use electricity consumption as a proxy for income. For model 3, we use the volume of electricity consumption, that is in kilowatt hour. For model 4, we use the value, the peso value of electricity consumption monthly. And why are we doing this? Because we note that household income is correlated with some of the household characteristics, and that will be violating the assumption in the regression assumption. And we note that electricity consumption is actually closely correlated with household income, so we can use it as a proxy for household income. We note that if the income is higher, there are more appliances, and more appliances would mean greater electricity consumption. And we note that with this, we come up with significant coefficient for electricity consumption, positive, just like income. The higher the consumption, which means higher income, the higher is the probability that they will be willing to pay for the program. Now, with this respecification of the model, we have additional statistically significant variables. These are education and delay in payment of electricity bill. And we note that education has a positive coefficient, meaning the more highly educated the respondent, the more likely is he willing to pay for the program. Higher education would mean more knowledgeable about the issues, environmental issues, climate change, and renewable energy, and therefore higher willingness to pay for the program. Delay in electricity payment implies that financial difficulties. So the less likely is the respondent be willing to pay for the program. Next, please. So using the coefficients and the formula I presented earlier, we came up with a mean willingness to pay of 13.7%. That is using the average income of the sample of 44,940. But the actual average income in Metro Manila during the time of the survey is 34,821. So we adjusted that mean willingness to pay using the actual average household income, and we came up with 10.6%. Now, using the Turnbull formula for the non-parametric willingness to pay, which is a lower bound estimate for mean willingness to pay, we came up with 7.4%. So we concluded that about 7.4 to 10.6% increase in monthly electricity bill is the average mean willingness to pay of households in Metro Manila. In peso terms, is equivalent to 197 pesos to 283 pesos, with an average household with an average monthly electricity bill of 3,000 pesos. Next, please. Yeah, so we note here in conclusion, rather low. The willingness to pay is rather low. Less than majority of the respondents would vote for the program and be willing to pay. And we note that if the bid or the price of the program is 50% or higher, 15% increase in monthly electricity or higher, only a third of the respondents would answer yes. And the estimate that we got for the Philippines is much lower than Chile's 16 to 19% and Southwest America's 36%. And we attribute this low willingness to pay for insufficient knowledge and appreciation of renewable energy as a climate change mitigation measure. So we see that people know more about climate change than renewable energy, and also because of the already high price of electricity in the Philippines. Okay, so let me go to the paper number 2. How much time do we have? Okay. So paper number 2 is using choice experiment to estimate willingness to pay for each renewable energy technology. Next, please. Next slide. Okay, so what do we do here? So we don't ask them, what is your willingness to pay for this specific program? What we ask respondents is that we gave them sample or choice sets, such as this. One example of a choice set, there are 3 alternatives in each choice set, and each alternative is described in terms of 3 attributes. The first one is the percent share in renewable energy, and the main type of renewable energy. So where is it coming from? The increase in renewable energy share. And the third attribute is the additional cost, electricity cost. So for alternative A, for instance, for this choice set, we have 50% renewable energy share. And this is coming from wind, and this will entail a 10% increase in monthly electricity bill. For alternative B, 40% renewable energy share coming from small-scale hydropower, and this entails a 30% increase in the monthly electricity bill. Alternative C is always a status quo, where the share of electricity is 30%, the current share, and it is being sourced from large-scale hydropower and geothermal, and of course, there is no cost, there is no additional charge in the monthly electricity bill. So on the average, each respondent is given 8 choice sets so that we can see the trade-off between the different attributes, how much they are trading off money for the share in renewable energy and for the type of renewable energy. Next, please. Okay, so these are the different attributes, the 3 attributes and the different levels that we use for the choice sets. And then next, please. So can we have the result? Basically, it's just saying that utility is based on the attributes of the good, not the amount of the good. That is the Lancasterian theory of value. And then we just assume that the probability that they will choose one alternative over the other is equal to the probability that the utility that will be derived from that alternative is greater than the utility that will be derived from the alternative that was not chosen. And since our dependent variable has different, more than 2 possible values, so we use the conditional logic regression to run our regression and to come up with the estimated parameters of the utility function. Next, please. Okay, we won't discuss. Let me discuss this because it shows us the familiarity of the different RE sources of the respondents. So the most known RE source is solar. 91.2% of the respondents say they have heard about solar power even before the survey. And the significant 95% believe that it's environment friendly. Next known is wind. 80% of the respondents said they're familiar with wind power even before the survey, and 92% of respondents are saying, yes, it is environment friendly. The important thing here is biomass. You look at biomass. Biomass, only 25%. So this is the least known RE technology. And also a lot of people, because it's not known, they say they're not sure whether it's environment friendly or not. So please, next slide. Okay, so this is the regression results. Now, all the explanatory variables are significant. Price has a negative. The increase in monthly electricity bill has a significant negative coefficient, meaning the respondent is likely to choose that alternative which has a lower price, which is again consistent with the law of demand. The share of renewable energy has a positive coefficient, significant positive coefficient, meaning the respondent is likely to choose that alternative with a higher share of renewable energy. So more renewable energy is desired. And now we have the coefficients of solar, wind, biomass, and small-scale hydropower, all positive, meaning respondents prefer alternatives with these RE technologies over the status quo, which is large-scale hydropower and geothermal. The more interesting part here are the magnitudes of the coefficients on which the marginal willingness to pay for each renewable energy type depends. So we note that the highest coefficient and therefore the highest marginal willingness to pay is for solar. So it's the most known and also the most preferred RE source. And this is surprising because next to solar is not wind, it's not small-scale hydro, but biomass, the least known RE source. And the marginal willingness to pay for it, 6.84%. And how do we explain this? So we note that before we gave them the choices, we actually discussed very briefly what those RE technologies are. And for biomass, the description is something like this. It is making use of waste materials such as agricultural waste and solid waste to generate electricity. And as we have seen earlier, solid waste is the second most perceived problem, serious problem in the Philippines. And that could be inducing people, the respondents, to choose alternatives with biomass. It's like hitting two birds with one stone, solving the climate change issue as well as the solid waste management issue. And as discussed in the introduction, next please, of Dr. De Guzman. Next, please. I don't think we have time, so let me move to conclusion. There is willingness to pay. The most preferred RE technology is solar, and there is leeway for the new renewable energy technology, especially biomass. So we can also focus, the government can also focus on developing biomass-based electricity supply. With this, I can end the presentation. We can now open the floor to questions and comments, suggestions. Thank you.
Thank you very much to our speaker. Let us give her a round of applause first.
Thank you. We made it 40 minutes, 39 minutes for 39.
Okay, so we are now in our Q&A segment and we are encouraging participants to raise their hands and speak up, or you may also type your questions in the chat box. Who would be the first one to ask a question? Okay, we have a question here in the chat. I think Dr. Tan can also see it. But let me read it. So this is from Dr. Magante. The question is for the first paper. The mean WTP in Metro Manila is significantly lower than Chile and the US Southwest. What factors contribute to this discrepancy, and how can the Philippines bridge this gap to increase support for RE initiatives? So, Dr. Tan?
First, I did not look very, very hard on the Chile's paper and Southwest America's paper. But on the part of the Philippines, I guess the one reason is that electricity price in the Philippines is already very, very high. We compare it with other countries in Southeast Asia, it's the highest. And so there is actually less openness for further increases in electricity price, despite the fact that it will be good for the environment. And second, it could be the income as compared with the US, awareness, and also appreciation of the issues. And yes, more of awareness of renewable energy, because people are quite familiar with climate change, but probably they're not so familiar with the sources of climate change, which would be electricity generation, use of oil and fossil fuels to generate electricity. And so I guess that link no, between renewable energy as a climate change mitigation technology is still very not known to people in the Philippines. Yeah.
Okay, thank you. So, next question, please, from the audience. Can we have the... Okay, this one is from Trixie Roque. I will read it. May you share on how small-scale hydro runoff river was described um, to the households and made it a least option. I'm not exactly sure what that
Yeah,
means.
we gave one sentence description. I don't remember anymore the exact phrasing, but I can check it. I can check the questionnaire probably later and you can email me. But apart from the one sentence description, we cannot make the questionnaire so long. It is already long. It's a 10-page questionnaire. We have illustrations, we have visual aids. So we showed them a picture of the run of river hydropower plant vis-a-vis the large-scale dam-based hydropower plant. I hope.
Okay, the next question is from Ian Dave Custodio, and basically he is asking about the second paper, and
Mhm.
the question is it
Yeah,
related to the so-called conjoint analysis, if you are
yeah.
familiar?
And that is the second paper, that's conjoint analysis, yes. The title of the presentation is actually the title of the second paper. I'm so sorry about that, but I decided no, little bit last minute to also discuss contingent valuation because the choice experiment method is a little bit harder to absorb no, the concepts to absorb. And it will be good to introduce stated preference method such as contingent valuation and choice experiment by starting with contingent valuation because it's a simpler model to discuss. Yes, you're right. The second paper is the title of the presentation, the presentation as advertised.
All right. So next in line, we have Tracy Lynn Oceanas. And the question is, given that you have discussed renewable energy sources like solar and biomass beforehand, I suppose they're talking about before asking the question or the survey. Do you think this could introduce an information bias when measuring respondents' willingness to pay? And if so, how do you account for this potential bias?
Yeah, so what we did was actually to provide the information so that they will have the same amount of information. Okay, at least they have minimum information. All of the respondents would have this minimum amount of information. Of course, those who are more knowledgeable will have a greater willingness to pay, and we actually look into this, and that is one factor that we have identified that influences no willingness to pay. So that is the purpose of presenting the information or the discussion, the brief discussion, description with illustrations of the different RE technologies. And we did not give any bias in the sense na mali yun, no? Or is overly exaggerated yung biomass and not the others. So it's just a one sentence description of these different RE technologies. And we did not over describe one particular RE technology. We just gave one sentence and very, very objective definition of what they are.
Yes, I
So we
suppose that's for information lang, no? It's just
Mhm.
meant to provide background information. Okay, the next question is this. Sabi niya, I just have one question. This is not just for the Philippines, but for the world in general. While we're at the topic of renewable energy, why does nuclear technology for electricity continue to be a taboo, even though incidents like Chernobyl were long ago, safety measures have become more advanced, and also what is the best way to convince the masses that nuclear technologies were trying? Well, I think this is outside the scope of Dr.
Yeah,
Tan's
unfortunately, I
paper.
did not look into this, no, for this
Yeah,
studies.
but if she has
Yeah,
an opinion about that, we can
yeah,
hear it.
yeah. So I don't think I will be able to answer the question. Yes,
Okay,
I.
that, yeah, thank you. That was from Paulo Miguel de Guzman. All right, the next question is from Alejandro And
Mhm.
we let Jose Tuason. Good afternoon. From your findings, did you
Mhm.
see what the percent share of energy consumption of a household of high-income households? Wait, did you see
Yeah.
the
Mhm.
percentage share of energy consumption of a household of high income versus okay, versus
Yeah.
low income?
Yeah, yeah. Okay, very interesting question. And actually, we're now looking into this in a new paper that we are writing. No, as I told you earlier, the first part of our questionnaire includes detailed question about electricity consumption of the households, including the appliances in the household. So we are now writing a paper on this, and we cannot still. So we are just processing the data as of now. At the moment, we are just processing the data, so I cannot say much about this anymore. Hopefully, I can present that paper later when it's finished, when it's done.
Okay, okay. But before I read the next one, there's a hand raised. Alejandro Jose Tuason, you want to speak up? Your hand
Hi
is
po.
raised. Sige.
Mm-hmm.
Can you
Go
hear me?
ahead, go ahead.
Can you hear me?
Yeah,
Yes,
yeah.
yes.
Okay. Hi po, good afternoon. Thank you for your research
You
kasi
know.
I'm a sustainable energy engineer. So this
Mm-hmm.
is I focus more on the supply side.
Mm-hmm.
Since dun sa nakita nyo dun sa data nyo na mataas ang preference, like super taas ang preference to solar, like it's double, I mean it's like double
Mm-hmm.
compared to everyone else.
Mm-hmm.
Since you're
Correct.
doing further studies into this, would you also look into, kasi ang solar panels,
Mm-hmm.
everybody, people's neighbors already have solar panels in their household. So like they
Mm-hmm.
see it on a more daily basis versus
Mm-hmm.
like wind and especially biomass where
Yeah.
there's no person unless you're an engineer would know what a biomass plant looks like. Wind
Correct.
turbines, if you're touring around the country, you would see it once in a while. Pero wala siya on a household daily basis. Like there's no household version of a wind turbine, or
Mm-hmm.
there are some household versions of biomass, pero that's not what you usually talk about. So baka may effect yon dun sa preferences nila. The fact that they can see that some of the people around them have it. Kasi like my house is solar powered.
Mm-hmm.
So like, and I'm an advocate too, and I show it to all my guests. Oh, look at my panels, look at my batteries, and then naliw sila. So
Yeah.
like, maybe down the road, that'll be part of like policy recommendations on how to increase awareness. Because like, how do
Yes.
you make, if you want people to pay for more like RE in terms of the other types like hydro, wind, biomass, getting it closer to communities where they can see it on a daily basis will have long-term effects on their perception. Like kung hydro, kasi most of the hydro are either in mountains, dams, which have negative perceptions,
Mm-hmm.
or yung mga run of what river. Pero like kasi like the things I work on a school level is maliliit na household level water, rainwater to power, so things like that. Pero wala pang viable. That's the problem. So yun lang. Basically, the perception we might be able to improve perception if you can get some of these technologies on a more local distance to populations. That's my idea. So like
Mm-hmm.
whether it's not household pero baka community level or city level, and then like sabihin natin like Pasig is proactive, they want to do rainwater catchment and then somehow may power down, or like I know of a waste company who's planning to do waste to power, for example.
Mm-hmm.
Pero wala pa, matagal pa yon. So those are the things that might help us improve the perceptions, and then maybe then people are willing to pay more, or through RE certificates, they'll say, no, I want RE. I want to buy from RE instead of buying from fossil fuel. Yun lang po.
Yeah. Yeah, thank you. I do agree with you. I couldn't agree less. No, indeed, no. Willingness to pay, as pointed out in the paper. If you are interested, you can go. You can get a copy of the paper from the Ateneo research portal. No, and indeed, it is shown to be dependent or correlated with awareness. Yeah. Thank
All
you for
right.
that.
I think in the interest of time, we have time for about two more questions. So
And Uh,
yes.
wait, can I also mention here that I also have a paper, recently published paper on rooftop household rooftops solar power preferences for this, if you're interested. Yeah,
All right.
thank
Okay, thank you very much. So, we have two more questions in the chat box. The next one is from our associate chair, Mr. Genesis Lontok. He is basically asking about the WTP for wind energy. It doesn't seem to be good at the moment, I guess, based on the study. But would you foresee this to be a trend over the horizon, or is there something alternative that can be done to boost it?
Well, information campaign. And yes, no, I think no more people really, because of exposure, as mentioned by the engineer who commented earlier, people are most familiar with solar power because of the rooftop solar power systems, and therefore there are actually that affects no willingness to pay. And then I guess the problem now with wind energy is awareness. We seldom see wind power plants here in Metro Manila. So that's why the awareness is low. But this can be addressed through policies nga, awareness, information campaigns, etc.
Okay, the last question in the chat is from Elvin Dulce. He says, why is it that other studies say that a larger share of RE will lead to lower electricity bills, but in this WTP study, respondents are being asked how much they are willing to pay more for a larger share of RE? Dr. Tan.
Thank you for pointing that out, because this is true in developed countries, because the cost of RE technologies are really going down, especially solar power. Okay, but the thing is, in developing countries like the Philippines, in Southeast Asia, the cost of renewable energy is still high for some reasons. One would be the business environment in the Philippines, the policy environment, no, which makes auxiliary costs of renewable energy still high. So this is also one of our recommendation, no. So government has to something, no, to reduce the auxiliary cost so as to make renewable energy cheaper, or the cost lower, so that the willingness to pay, this will match, no, the demand for renewable energy. Yes, that's true for developed countries, but not for Southeast Asia yet, not yet here, not for the Philippines yet.
Okay,
Thank you
thank
for
you
that
very
question.
much. So let us again give a round of applause to our speaker.
Mhm.
All right. For the other questions in the chat or comments, we will look into them and our speaker will maybe get back to you. Meanwhile, as we close our program, so on behalf of everyone here, we sincerely thank our speaker and don't miss out. Visit our website to access materials from previous seminars and stay informed on past discussions. All right. So catch up on our previous seminars. Visit the Ateneo de Manila University YouTube channel and explore economic seminar series playlist to watch past discussions. Also, before we wrap up, a quick reminder, if you'd like to request a certificate for today's session, the link to the request form can be found in the chat box. Please make sure to complete it immediately as the form will only remain open for 2 hours after the session. Finally, next slide, please. We would like to take a moment to thank our incredible support team for their hard work and dedication in making this event a success. Their names are right there. We also extend our gratitude to our attendees and look forward to you joining more of our seminars from February to April. And your engagement and support have been invaluable, and we look forward to your continued patronage and participation. So thank you very much, and we look forward to seeing you again. Now, Nika, our graduate assistant, will now facilitate the picture taking. So can people please open their cameras for picture taking purposes? Just let us know if it's already done.
Yes, po. Okay, please open your cameras. I'm just waiting for you to open your cameras. Okay. 1, 2, 3. Okay, for the next one. 1, 2, 3. Okay. Last one. 1, 2, 3. Okay. Thank you.
We're done. Okay, thank you very much. Have a nice rest of the day.
Thank you.